Hello everyone, welcome you all to the series of MATLAB tutorial. In the last session, we have covered MATLAB matrix. Now we will learn about MATLAB functions. We will begin by what is function in MATLAB, then basic syntax, how to work with nested functions, common application of matrix functions, and as usual, for your better understanding, I'm gonna keep this session mixed with the theory part along with a live demonstration of a MATLAB scripting examples. So let's start. So we are looking here, what is a MATLAB function? So in MATLAB, a function is a small piece of code that performs a specific task. A function is a group of statements that together perform a task. It helps you to reuse code instead of writing it again and again. In MATLAB, functions are defined in a separate files. The name of the file and of the function should be the same. If you do the mistake, if you save the file with a different name, the function will not run and it will throw an error. So it is very important to understand the name of the file and the name of the function should be the same. And by default, if you create any function in a MATLAB and if you hit the save button in mscript, then it gives you by default the name of the function. Functions operate on variables within their own workspace, which is also called a local workspace. Separate from the workspace you access at the MATLAB command prompt, which is called the base workspace. So what is important, where you are storing your or saving your MATLAB function, you need to keep that path open. So whatever the operations you want to perform on a function, the MATLAB calls that function from that location. If you keep the different location, then it throws an error. Functions can accept more than one input argument and may return more than one output argument. So this is all about what is the MATLAB function. Now the next point is why is the function and why it is required in the MATLAB function and what is the approach behind the MATLAB function. First point is a reusability. So same function works for any data set. So why the function approach is better? And the one reason is a reusability. The clearer code, script only handles input-output logics inside the function. Scalability. That is another important point. It is easy to add more calculations without cluttering the script. And the last is a collaboration. So functions make more modular and understandable for teams. So these are some approaches which makes you function better when you deal with the MATLAB scripting. But to understand in detail why the MATLAB function rather to use the conventional programming method like you're writing the code line by line, let's understand with the example. So I'm going to take the example of calculating or computing the average of the data sets. So inside the conventional method, we call it as a script method. Let's use the data as a set of the array. It is a 10, 20, 30, 40, 50. Taking very simple example, okay? And want to perform the average. So what I did, I used the variable average. Then I'm doing the sum and then dividing the length of that the data set. So length is here is a 5 and doing the addition. This is how the simply the average function will perform. Then I will perform the standard deviation, square root of the sum of the data minus then I put this formula and again the divided by the length of the data, then it will give the standard deviation and I will display both like average is equal to I used the number to string inbuilt function on the average. If you see here the average here, I'm doing the average. So average is equal to addition of all these numbers and then the dividing the length of the data set. That is how many numbers are there. It's a 5. So I will get the output as a display. That is, it will show you the average. That means the result of this operation. And this is how in the conventional method you will perform the averaging operation. And if you want to display the standard deviation, then I will just call that dev function, standard dev function, whatever the function is written here. And under the numbers to string, that means it will display here in front of the text, that is standard deviation. Okay, but what is the issue with this approach? If we go with simple computing the average of the data set with the conventional method that is called a scripting method, there are a few issues with this approach. Let's look one by one. So first is a code is not reusable. That means if you want to calculate for another data set, you must edit the script. Just imagine I am doing the standard deviation and the average for these numbers. But tomorrow, if I want to do the averaging of the different numbers like 50, 80, 90, 100, and the length of the data set is also different, then what I need to do? I need to come inside here and change the data sets. And that is the reason it is called the code is not reusable, right? So you need to change or edit your script if you want to work or if you want to calculate for another data set. If you want to calculate the average or standard deviation, definitely you need to edit your script. That is the one reason. And the another reason is the harder to maintain when logic grows. Now, just imagine this is a 5 or 6 lines of the code. It's easy. You can go into the script. It's a manual work. Yeah, okay. You can change it. That's okay. But if the code grows, means if you are working on the 100 lines of number of the code, then definitely it goes difficult and it goes harder to maintain when the logic grows. And the last reason for the issue with this approach is clear modularity. So there is no clear modularity in this approach. And that is the reason we use the MATLAB functions rather to use coding with the conventional methods. Now let's look the same example to compute the average of the data sets. And the method I'm gonna use here is a MATLAB function method. The first, what I want to do, I want to compute the average and standard deviation, that is expectation from the coding. Then I use the function and I passed average and standard deviation as an argument over there. And then I compute state and passing the data over there. And I'm just putting this formula here, average, sum of the data, same equations I put. What is the flexibility is added in the code. When I run this function, that time I'm just passing the data. So it is giving the flexibility to change the data. Then again, standard deviation formula is created, the same formula you will use here. And then I am ending the function. It is very important when you start the keyword function, then you need to end that keyword as well. What is the benefits with this approach? Just simply look at the code and then you will realize benefits of this approach is code is reusable. With just passing, when you run the code or when you run the function, you just need to pass the data sets and it will automatically calculate. So code is reusable. Here you can easily maintain the code with as the logic grows increasing, and clear modularity is visible here, and that is the reason we works on the MATLAB function rather to work on the conventional method, that is a scripting method, means the line by line code, that is conventional method actually. Let's look for the function basic syntax. Now, how the basic syntax works in the MATLAB. So in MATLAB, a basic function is defined using the function keyword, and which is followed by the output variables, function name, and its input arguments. Let's look this general syntax, how it looks. And here is the basic syntax, starting with the keyword that is called function, and then followed by the output variables. Okay. And then what I'm doing, I need to write the function name here. So when you run the code, you just have to write the function name and pass the arguments. And then it goes the input arguments. So input 1, 2, 3, whatever the arguments you want to pass. And these are the outputs you are expecting. Then what you have to do? You have to write the logic inside this function on this output variable, how you want to perform. Inside the part of this function body is called a function body. And here you perform the competitions. That means output 1 is equal to, let's say I'm just doing in input 1 into 10 or input 1 divided by 5 or something like that. That will come under the output 1. So here we are performing the calculations, doing the actual calculations on the output variable. Then output 2 is equal to xyz, and without means we have to end this function. This is a very simple syntax used in the MATLAB function, starting with the keyword function followed by the output variables, that is the variable which you want to compute, and then the is equal to and the function name, whatever the name you want to assign to the function, and then passing the input argument. And then this is the function body. Here you can perform the operation on this output variable. And as you open the function variable in the MATLAB script, you need to end that function. What are the key components here? If you look at this, basically, the function basically is a keyword to declare the function, and output arguments are enclosed in the square braces. If there are multiple outputs, omit braces for a single output. Function name, that you must match the file name. Whatever the file name you are giving, that match with the function name. So here we should keep the file name as a function name.m. Input arguments, which are enclosed in the parentheses and can be a 0 or more. And the last end is the optional for the single function files, but recommended for the clarity. This is how in function, what are the key components comes. Name of the function, that is the keyword, then keyword, that is the end, then input argument, output argument, function name must be the same as the file name. That's all about the MATLAB function. Now time for the nested functions. So nested functions in a MATLAB is simply a function defined inside another function. The outer function contains one or more inner functions. Inner functions can access variables from the outer functions without passing them as an input. Useful for organizing the related tasks together. And it keeps related logic together for better readability, and it also avoid the global variables use cases. Because why we want to avoid the global variables, there are multiple reasons. Global variables are really hard to track changes. It is very difficult, and it uh, with the help of this global variable we cannot reduce the code complexity or the readability. Debugging complexity goes increasing, and poor modularity. When we say hard to track changes, any function or script can modify a global variable, making it difficult to know where and why it value changed. It comes for reduced code readability. That means when variables come from the outside of the function scope, the logic becomes unclear and harder to maintain. Debugging complexity. That means bugs related to a global variable are harder to find because the variable state depends on the multiple places in the code. And poor modularity means the function should be independent and reusable. Global variables creates hidden dependencies, reducing flexibility. And that is the reason usually we want to avoid the global variable. And there we use this nested functions, which literally avoid the use case of the global variables in your program. Now let's look for different MATLAB function applications. In MATLAB, functions have wide range of applications across engineering, science, and enterprise environments. Based on internal and different resources, here are the key areas where they may be or more commonly used. And then the first one out of that is data analysis and signal processing. Here, the MATLAB functions are essential for tasks like statistic analysis, filtering, and transformation of the data. Also, under the data analysis and signal processing, signal and image processing for automotive, aerospace, and industrial application. Handling large data sets efficiently using the modular code. And the example for that is the functions for importing and processing measurements data from Inca to MATLAB workspace. And Inca, again, it's an engine calibration tool. You can um, import as well as process the measurements of that the calibration variables into the MATLAB workspace, and that's possible. For that reason, it is falling under the data analysis and signal processing. The next area is a control system and simulation. Here, the functions are used to model and simulate control systems in Simulink, enabling rapid prototyping and testing without physical hardware. For embedded systems, embedded coder generates C code from MATLAB Simulink functions for embedded systems. Example, vehicle function simulation and code generation for the ECU development. The next area is application development and deployment. Build iterative apps using the MATLAB App Designer and package them as a standalone executables or MATLAB web apps. That's possible. Deploy MATLAB functions as a microservice APIs integrated with enterprise IT systems for predictive maintenance and anomaly detection. And I think there are multiple applications like model-based design and automation. There automate workflow and testing framework for apps and simulations. Then specialized engineering applications where robotics, wireless communication, automotive system simulations, and AI-driven design. Functions enable integration with toolchains for calibration, debugging, real-time simulations. And those are the common applications of the MATLAB functions. Now the time for looking some MATLAB examples. We will see simple MATLAB function examples, and later we will see the nested functions in a MATLAB. I have already created a few examples to save your time. And for the MATLAB functions, very simple functions, a program I have created. We'll start with just adding the two numbers and then calculating the square of the number. The two examples fall under the example of MATLAB functions. Here, if you see on the current folder, already created the functions, or I would say the script, but it is a function itself, and that's the basic rule. Let me open the add two numbers. Okay, so this is a simple script created here. I'm just adding the number. And if you see here, the name of the function is, here we are starting with the keyword. If you look at or remember the theory part where I explained the basic syntax of the MATLAB function, start with the keyword, the output, and then the name of the function and the input arguments. And here is the output, and how I want to perform the output, as I just want to add the two numbers. Results is equal to, or result is equal to a plus b. It's a very simple example and I will show you how to run it. But before that, I want to tell you one thing, that the name of the function should be always the name of the file. And if I go like this xyz, let's say here xyz I wrote, and this is the name of the function. And if I hit save, then you see here, it will throw an error and it will not run actually. So one thing is clear. Let me remove this, add numbers. Okay. And let's do one thing. What I wanted to show you, like here, and if I go with the new function, let's say the name of the function is test function. Okay. And under the test function, I just want to assign the a value to the result. And if I want to save this, okay, I will not use this, let's say this way. And if I save this, what I want to show you, MATLAB by default suggests you save the MATLAB function file by function name itself. So if I hit save, see here, by default what it is suggested, it is suggested the test function. That means you always use the name of the function as a name of the file to store or to save. That is what I wanted to explain you here. So very simple example I have taken. I'm starting with the function keyword, then output, the name of the function, and passing two argument because I want to add the two numbers. And here I have written a plus b and passing the result here. Now, if this is saved, no need to run even. If it is saved in the same workspace, I am in this workspace and I'm running this. So what you want to run, how you can run this? The running very simple. You call this function. Either you can simply you can call this function add and numbers. Okay, open the curly braces and how many parameters you have passed or the argument you have passed. You see here, it is suggesting us the A and B is passed. So ideally I need to pass two numbers. Let's say I'm passing 10 for the A and 30 for the B. And if I enter, it will show me the result as a 40. So it is added the value. If you are a beginner in the MATLAB and you want to run the any function in the MATLAB, my suggestion is just look at the keyword function and look the name of the function. It always appears after this is equal to sign. This is the name of the function and look for the how many arguments it is in passed. If it is the three arguments are passed, two arguments are passed, use the same number, keep here the same name, actually not a number, and then pass the numbers over there and you will get the result. So this is how the function works. And this is very simple example. Taking the another example is calculating the square of a number. Here I want to calculate the square of number. If I give the 10, then I should get the answer 100. If I put the 5, I should get the 100, answer 25. If I put uh, 25, then I should get the 625 answer. That's what I'm expecting. And again, I'm starting with the keyword function. And here I use the one output variable. And for that output variable, created the function name square and passing the input because I just want to calculate the one variable's square value. And here it is written like x into x means the same number is multiplied. That means you are getting the square and returning that to this function. So if I clear this workspace, very simple, okay, and clear the screen as well. And you see here, just use this as a square, okay, or you can do like this, y is equal to and the name of the function and pass any value, whatever the function you want to calculate and hit enter and it is calculated the square. Let's go for anything you can calculate here. So let's say 25, enter. If I calculate the square of the 3, then it will give 9. So very simple. And this is how it works. So these are the very simple examples of the MATLAB functions. Now, so far we have seen the two examples under the MATLAB functions, very simple examples, that is the addition of the two number and the calculating the square of the number. We understood there how the MATLAB function works, how we are passing the arguments and it is getting assigned to the output variable, how to run the MATLAB function, what is the need of storing the same file name as the function name, that also we have seen. Now time to look for the nested MATLAB functions. And for your time saving, what I have done, I already have created the scripting which covers the nested MATLAB function examples. So we'll start with this code here. So the first example I wanted to show you is we can start with this main function. And this is an example of the nested MATLAB function. And here I'm starting with the name of the function is equal to main function. And that is the reason the name of the file is also written as a main function. MATLAB is a case sensitive language. You cannot use the small f here, otherwise it will throw an error. You cannot use the M as a capital here, it will throw an error. And if you want to keep the capital M here, you need to make sure that you are keeping the capital M here in the name of the file when you are storing. And you need to store the same file in the workspace. Otherwise, your function will not get called and you will face the error while running your program. Simple program created here. What I'm doing, this is outer function where I'm displaying the input value and I'm passing some value. And in the nested function, I'm calculating the square value. How it is calculated, whatever the value is passed to the square value function, that is get multiplied with the same. That means the square is calculated and output is assigned to the y. And here we are getting the result. Okay, that is result is equal to square value of, that is a square value of x, and we are displaying the square value. So let's run this. How you will run this? Then I will write like this. I will use the main function as it is, and I will pass that value. What value I want to use? The value is simply I gonna use is, let's say, the 10, and let's see how it works. And if you enter, you input the value 10, but here this is outer function. You got to know that what value you have inputted, and as well as in the nested function it calculated the square as well. And then you got the square value here, that is the square of 10 is 100 basically. Let's look for the another example. Let's say I write here 45. Then here is the square for the 45. If I go for 39, then you will get a square of the 39. So this is how effectively you can use the nested form of the MATLAB function, that the output function works as the main function, and inside that you are calling the another function. So inner function can access the variables from the outward function without passing them explicitly, and keeps related logic together for the better coding. So you see here, there is no need to pass explicitly your input function. So input function is it is accessing the variables from the output function, and there we have not passed explicitly, and the logic is actually related to each other, and it is executing the value. And this is how the nested MATLAB function can be used. Very simple example, but you can understand it and then you can start developing your own logic for your programming. Another example I wanted to show you here. Before that, I will clear the screen here as well as I will clear the workspace. So now the another example I want to show, let's take an automotive example. And the another example for the nested MATLAB function is to calculate the engine power actually. So we are calculating the engine power, and so with the help of, we are calculating engine power actually, not the torque here. So let me correct this. This is outer function. Outer function is, name of the function is engine performance. What I'm passing, RPM and the torque. Okay, so I will give that value, and here in the nested form, I'm calculating the power. Very simple. Use the variable power. Calculate power is the name of the function, and I am just passing that RPM value and the torque value. Just imagine, here I started passing that values, but it is explicitly not asking to call that values inside here. It is taking that value and doing the calculation, torque and this RPM value, and then this is the formula, and then you get the power calculated. Okay, and here I am displaying that like power output is equal to calculate power, and the displaying that engine power is equal to in the kilowatt. Now let's see how it works. And this is very simple example again, but very important for you. As I said, like start with the name of the function, look how many parameters are or arguments we have to pass, and try to use the variable name such that it will give the clear message that what you want to pass. So here I want to pass the RPM. So let's say engine RPM is 2000, and then comma, and I want to pass the torque. So let's say I'm passing the torque as a 20 Newton meter. The unit is Newton meter, and let's enter the hit button. So here engine speed is in input for as an engine speed is a 2000 rpm. Torque is at the 20 Newton meter, and you are getting the value of a 4.18 the kilowatt power you will get from the engine. Ideally, this nested form of this engine performance calculate the engine power, and that is the reason I made the correction here. It's calculating the engine power. Now let's understand this, because you see here the 2000, this is um, if you want to calculate the power, we need to convert this into radian per second. So how I will calculate that radian per second? 2000. Let's do the manual calculation and check either this function is working properly. 2000 into pi by 30, right? So I'll use the keyword pi and then divided by 30. Okay, and I will multiply it with this torque, that is a 20 Newton meter. So SI units are used, and I'll use this multiplication here, it will work, but let's do that and then hit the enter button. If you see here, if I increase this portion, 4.181885 kilowatt, and here 4.1888 e raised to 3, that means the kilowatt. So this is how you are calculating the power. And let's fade another value over there for this. Let's do for the 3000 rpm if engine is running at high speed and delivering the higher torque, let's say 40 or something, or let's take very high value, that is 90 newton meter or something. And if you enter, you can get this much of the value. Even I can go, let's say I'm getting the higher torque, it is a bus application, let's say 180 newton meter of the torque I got. Then this is how the 56 kilowatt of the engine power you're gonna get if you have the engine RPM of 3000 and the torque is 180 newton meter. This is again the best example, very simple example, the automotive example to understand how the MATLAB nested function works, and the inner function easily access the variable from the outer functions without need of passing them explicitly. After watching this video, I'm sure that you understood what MATLAB functions, basic syntax of MATLAB functions, how it works, and why it is needed. If you really like this session, then please give this video a thumbs up. To watch more videos like this one, please consider subscribing. Once you hit the subscribe button, you're gonna get the notification anytime new contents like that comes out. And lastly, if you have any queries on this topic you wanna answer me, leave me a comment below. I read them all. That's all I have for you today. Hope you enjoyed and hope to see you next time. Bye bye.